Okay, so this next part, we're going to be looking at finding equivalent fractions. The good news is a lot of this kind of information we've done in the past, because one of the things that we're going to need to kind of figure out is, if you remember way back in the beginning of the year, we talked about lowest common multiple, so the LCM. And that's a skill that you're going to kind of use when you're thinking about trying to find an equivalent fraction. So if I were to ask you to put these in order from least to greatest, just by looking at them, it's pretty tough. Like if you have a mathematical brain, amazing. But it's really hard to look at 5/8 and compare it to 4/5 and compare it to 3/4. And it's because all the denominators are different. So what you have to look at is making these denominators all the same, because once they're all the same, you can easily compare them. So in order to do that, you have to look at creating an equivalent fraction. So an equivalent fraction means any fraction that has a different numerator and denominator, that the value of that fraction is the same. So we need to turn these into an equivalent fraction. And the way that we do that is by making, like I said, the denominators the same. How do we make the denominators the same? Well, we have to find a number that all four of these numbers equally go into, and it's got to be the lowest one. We don't want to just get the highest one. We want to think about the lowest one because it's going to make life easier for us. So in a situation like this, where it's pretty easy numbers, I always recommend looking at the highest number, so 8, and count up by the multiples of 8. So as you're counting up, see if these other two numbers are going to fit into that. Now here, if I'm looking at this, I already see there's an issue. I have a 5, which means that my number that I'm going to get that's going to have all three of these numbers in it has to end in a 0 or a 5. So I'm going to count it up. 8, 16, nope. 24, nope. 32, nope. 40, okay, let's think. So 40, I know 8 goes into 40. 5 definitely goes into 40, and 4 goes into 40. So that becomes, now I say to myself, okay, that becomes my new denominator for all three of the fractions. At this point, I'm going to ask myself, okay, what did I do to get from here to here, from here to here, and from here to here? So to get from 8 to 40, I multiplied by 5. To get from 5 to 40, I multiplied by 8. To get from 4 to 40, I multiplied by 10. Remember, way back, we've always said whatever you do to one end, you got to do the other. So if I multiplied by here to get by 5 to get to here, I've got to multiply by 5 to get to here. So I'm going to multiply 5 times 5, and I'm going to get the number 25. So 5/8 is equivalent to 25 out of 40. Here, I multiplied by 8, 5 by 8 to get 40. I have to do the exact same thing up here. So I've got to multiply 4 by 8, and I'm going to get 32. So that means that 32 over 40 is the equivalent to 4 over 5. And here I multiply by 10 to get there. So I'm going to multiply the 3 by 10 to get to this area too. And so I'm given 30 over 40. So again, all equivalent fractions. Now when I look at it, I see, okay, all the denominators are the same. So now I can just focus on the numerators and put them in order. So if I were to now order them from least to greatest, it would be, and this is the problem, I have to return back to my original fractions. 5/8, right? It's 25 out of 40. Then 3/4, 30 out of 40. And then 4/5. So again, finding the equivalent fraction is all about making sure that your denominators are all the same, figuring out how did you get from one denominator to the new denominator, and then approaching the numerator with the same way. So again, if you multiply by 5, you're going to multiply by the numerator by 5. Let's do another one. Let's do one that's a little bit more challenging. So here we're going to do the same thing. We're going to put them in order, but here we've got a 5, an 8, and a 7. Now, I know that it's going to have to end in a 0 or a 5, and I can count up by the multiples of 8, but it might take me a while before I get to the point where I know that it's going to be 7, right? Because I'm going to have to count by multiples of 8 and by 7. So when I'm faced with this kind of scenario where I'm given a bunch of numbers, These 5s are going to just cross each other out. I'm only going to represent them by 1 5. And here's the easy trick. What I'm going to do is I'm actually just going to multiply all the denominators by themselves. So I'm going to multiply 5 times 8, right? So I'm going to multiply this and this together. That's going to give me 40. I'm going to multiply that number by 7. And I'm going to get 210. This number is the least common multiple of all of these numbers, right? If I thought about LCM, for LCM, when I'm figuring out LCM, it's the common factors times the remaining factors. Well, the remaining factors are 5, 8, and 7, which is what I did here, right? And 2, 3. So that's the lowest common multiple. So I'm going to now create my new denominators. And I'm going to have to ask myself, okay, I'm going to have to do some division here and then think about it in the other way. So how did I get from 210 to 5? Well, I divided by 56. That means that the opposite way, from 3 to here, I'm going to multiply by 56, right? Because I'm going from bigger to smaller, and here I'm going from smaller to bigger. So when I go from bigger to smaller, I'm always dividing. I'm going from smaller to bigger. So I'm going to 3 times 56. That's going to give me 168. Again, an equivalent fraction. 168 over 210 is 3 over 5. Same thing here. How do I get from 12 to 5? I divided by 56. So 12 is going to have to be multiplied by 56, and it's going to give me 672. How to get from 210 to 8? Well, from 210 to 8, I divided by 35. So from 210 to 8, I divided by 35. Means I have to multiply by 35 now, and that's going to give me 105. And last but not least, how did I get from 210 to 7? Well, I divided by 40. So I'm going to have to multiply 6 by 40, and that's going to give me 240. So now that all of them are in order, I can easily solve this, right? So my least to greatest, what's the lowest number? Well, it's 3 over 8. The next least is 168, 3 over 5. The next least is 6 over 7. And then obviously we could kind of tell our improper fraction was going to be the biggest one, right? So 12 over 5. So a very, very brief way of doing this. I'd like you guys on this next one to do the following. I want you to approach these numbers. So I'm going to give you guys 19 over 10, 11 over 3, and 9 over 4. And what I'd like you to do is do the following. I'd like you to put them into least to greatest, and I'd like you to write them as a mixed number at the end. Okay, write as a mixed. Okay, so pause the video here and please get started. Go. Okay, so we should be back. Let's solve this one together. On the other ones, I did the math earlier, and I just realized that I'm going to have to do the math with you guys. So let's count up by tens, right? We got to find equivalent fractions. We need to find a new denominator. 10 is the largest number, so let's count up by tens and see if they both fit. 10, 20, 4 goes in 23 doesn't. 30, 3 goes in but 4 doesn't. 40, no. 50, nope. 60 divided by 4 is 15. 60, yep, okay, so we got 60 as our answer. So we're going to have this, and this, and this. How did I get from 10 to 60? I multiplied by 6. So 19, oh, we're going to have to get the calculator out again. Sorry, guys. 19 times 6 times 6 is 114. Thank you guys for bearing with me. 114. How did I get from 3? I multiply by 20. 11 times 20 is 220. And I multiplied by 15. 4 times 15, so 9 times 15 will give me 135. So when I look at them, I say, okay, I've got all these answers the same. I have to look at the top. What's the smallest number? Well, 19 by 10 is surprisingly the smallest number. Second smallest number is 9 over 4, and then 11 over 3. That's part 1, right? That's my least to greatest. But I also asked you to write it as a mixed number. So let's take it to the next page and write them as mixed numbers. My first one was 19 over 10. How many times does 10 go into 19? Once. What do I have left over? 9 over 10. So 1 and 9 over 10. The second one was 11 over 3. How many times does 3 go into 11? 3, 6, 9. 3 times. I'm left with a 3 here. What's left over? 11 minus 9 is 2. And the last one, 9 over 4. I think we did this one earlier. We know it's 2. And what's left over? 1 over 4. Okay, excellent job, guys. So that's pretty much finding equivalent fractions at this point. You will need to know this kind of stuff for when we get to adding, subtracting fractions, less so multiplying, dividing. That's more straightforward. But when we get to adding and subtracting, equivalent fractions is pretty much the heart of it, okay? So we have one more part, which is simplifying fractions. So we're gonna get to that ASAP.